In this series of short lectures, we are going to study schema refinement. And we are going to start with problems with redundant storage. And this is Yücel Saygın, and these slides, video lectures are prepared as online material for CS 306 course offered at Sabancı University in Turkey. Here's the learning plan. You have to know what a relation schema and relation instance is. This is why we'll start with a review of those concepts. We'll then understand what are the problems with replicated and therefore redundant data storage. We call these problems insertion, deletion, and update anomalies, and we're going to study in detail what we mean by those anomalies. Let's look at this very simple relation that is created for students. The schema of this relation is the part that is yellow. So we have three attributes in this relation: student ID, student name, and the address. And we call this the schema. The instance, on the other hand, is the actual rows which are included in this relation. In this case, we have a relation instance with 4 rows for student 1 through student 4 with corresponding values for the attributes. Now let's look at another relation which I called stu_co, which has 5 attributes. Some attributes are related with a student, some are related with courses, and this also includes enrollment information. Let's look at the first row for student 1, whose name is Ali, whose address is Ankara. And we have another row for the same student, whose name is Ali and who lives in Ankara. So we are repeating for the same student the values for the name and address. Similarly, for a course, let's say we have a row for student 2, whose name is Sarah, who lives in Istanbul, and she was enrolled in a course with ID CS300. And the name of this course is DS, stands for Data Structures. And we have another student, Ahmed, enrolled in CS300, same course, and we repeat the name of this course, Data Structures. So the problems with such replicated storage of data, in this case for each student storing the name and address, and for each course storing the course name, for each enrollment, we may have insertion anomaly. Let's understand what we mean by insertion anomaly. Let's try to insert a new student to this relation. A student with student ID S5, whose name is Veli, who lives in Yozgat, or who is from Yozgat. So we have inserted this student, but maybe this student was not enrolled in any course. So we don't have anything, any value, any information to put for the course ID and the course name. So we cannot insert a new student without this student being enrolled in a course. This is a problem. Similarly, let's say we want to insert a new course. Let's say a new course has been designed, which is CS 101 in this case, whose name is CT, Computational Methods for Approaches for Thinking. And we cannot insert such a course without the first student being enrolled in this course. Another problem here. So how about when we are inserting such rows, we just include null values for attributes that we don't have any values yet. But we know that null values in databases are problematic. So we don't want rows with null values, and they will create further complications. So basically, insertion anomaly means that we cannot insert a record, let's say in this case for a new student, without an associated course. And similarly, we cannot insert or record a course, information about a course, without an associated student with that course. The second type of anomaly we have in this relation is called deletion anomaly. Let's say that the student with ID S1 leaves the university. So we have to delete all the records that belong to this student, which are the first two rows. So after we delete these two rows, we also lose information about the course, which was CS307 with name OS, operating systems. So we have deleted, we just intended to delete the information about the student, but we also lost information about the course, the fact that it exists, and the fact that its name is operating systems. So basically, deletion anomaly means that when we delete two rows in this case, or more rows, or even a single row, in this case for student S1, we also lose the fact that there's a course specific entity with name CS307 with name operating systems. Let's see what we mean by update anomaly. Let's say we update the address of student 1. The old address was Ankara, and he moved to Konya. If we just do an update on the first row, but we forget to update in the second row, then we have inconsistency in the data. So we have the same student with two different addresses, and we don't want inconsistencies in our database. So here's a summary. When we have a relation that's not carefully designed, we'll have replicated data and redundant storage. And this will lead to problems, which we call anomalies, more specifically insertion, deletion, and update anomalies. And the whole idea of schema refinement is to eliminate redundant storage and this way preventing anomalies.